Today's lesson is on solving exponential and logarithmic equations. First of all, let's take a look at a couple properties of equality. If you have two exponentials and the bases are the same, then the exponents must be the same. So what you can really do is just take the exponents and make a new equation if they're the same. Also, if you have two logs with the same exact base, then you can make a new equation with the x and y. So let's see how that's going to affect us in today's lesson. First of all, let's solve 3 to the x equals 81. Let's try to make both of the bases the same, and then we can use that property of equality. First of all, hopefully you realize that that's 3 to the 4th power. Now that the bases are the same, we can simply write a new equation with the exponents. Same base means same exponent. Okay, let's try again. We have a 16 for the base here and a 2 for this base. 16 is 2 to the 4th power, so I just took the 16 and substituted 2 to the 4th. But now I also have to put the x that was here. I have to bring that down. So now, once again, we have the same base. So now I'm going to make a new equation with just the exponents. And now I need to solve. And x equals 5. We could double check our work, but exponential equations do not have extraneous solutions. Let's go to example 3. Why don't you give this one a try on your own? Go ahead and pause. Okay, hopefully you tried that out. I'm going to take the 9 out and substitute 3 squared, but make sure to put the exponent here in parentheses because the 2 needs to distribute. Here, I'm going to turn 27 into 3 cubed, 27, so that's just a direct substitution. And in parentheses, I have 2x plus 3. Now, same base, same exponent, new equation. So as you can see, solving exponential equations aren't too bad. Don't forget to distribute. And you know me, I like my variable on the left, but it's okay if you put it on the right. So we have x equals a negative 11/4. Alrighty. So now we want to make both bases the same. We can't. And the first thing we see here is that we cannot make both of the bases 2. So what we're going to do is we're going to grab our calculator. And here's a hint that you needed a calculator because it said round to the nearest hundredth. So here, what you want to do is convert to logarithmic form. Convert to log form. Okay, whenever you can't get those bases to match. So recall, exponent equals log of the same base. And you see how easy that became just by converting. Okay, let me Get that out of there. That looks weird. Okay. So now, hopefully you recognize that log base 2 of 17 is just a number. We're just going to have to punch that into the calculator. Be very careful that you do not try to subtract the 3 from 17. Order of operations locks the log together. You do logs before subtraction. So now we're going to punch this into the calculator by changing it to base 10. So definitely grab your calculator. I like the Desmos scientific calculator. It's a great one. If you punch that in, you get x is approximately, and it says nearest thousandth, so that's 3 decimal places. And so we get approximately 1.087. Make sure you lock that part together and then subtract the 3. Okay, example 5. We're going to go ahead and start solving some logarithmic equations, but very, very important warning. Logarithmic equations have extraneous solutions. Okay? However, these are super fast and easy to check because you just have to make sure what you're taking the log of is greater than 0. So when I put my x in here, I have to make sure that this remains greater than 0 when I do my double check. Okay? So anyway, let's go ahead and solve. And I have a few steps for you. I know everyone loves steps. So the first step is to write as a single log. We already have a single log here. I'm saying that step in case you have multiple logs in the problem. Then you're going to convert to exponential form, then solve for x, and then double check for extraneous solutions. So right now I want to convert to exponential form. Base, the exponent is 2. Remember, the log equals the exponent. And wow, look how easy that got by converting to exponential form. That's the key to solving. If you can convert, this is going to be a super easy lesson for you. So now that's just 49. And I'm going to subtract 3 from both sides. So x equals 46. But now I have to check for extraneous solutions now that I have my x by itself. So I'm going to 46 plus 3. And already I know that this is a good solution because this number is greater than 0. But you can go ahead and check it all the way. And 7 to what power is 49? 2. And I can see 2 equals 2. Just check. Make sure this is positive. Okay? Not 0, not negative. But it's got to be greater than 0. Alrighty, let's see if we can follow the steps for example 6. First, we want to write as a single log, so we can use our properties. They have the same base, so we can multiply here. That's 4x. And now, base exponent equals 4x. Remember, once you write it as a single log, you have to convert. That's the big step that students often forget. We must convert to exponential form. So now 4x equals 36. I'm just using the symmetric property to flip that around. And I'm dividing by 4. X equals 9. So now I'm going to double check. When I punch in 9 and I punch in Well, at this point, I can already see that it's positive here and positive here. So I know this is a good answer, and I don't have a problem. But I could continue on, and as a matter of fact, I think I will. 4 times 9 is 36, and 6 to what power is 36? 2. And I can see that's equivalent. Alrighty, let's solve this equation. Remember in the very beginning, I showed you the properties of equality. If you have the log, same base on both sides, and there's nothing added or subtracted, nothing, just equal sign, same base, then 4x minus 7 equals x plus 5. Pay close attention because you'll have that one of these in the homework. Alrighty, and now I can simply solve this equation. So same log makes it real easy. Okay, so I have 3x here, and I'm going to add 7, and I have 12. X equals 4. I have to double check that these two positions are positive. So 4 times 4 minus 7, that's definitely positive. And of course, 4 plus 5 is also positive. I'm just checking, must be positive. In both of those positions, you cannot take the log of 0 and you cannot take the log of a negative number. Alrighty, let's look at this problem right here. We want to combine these to a single log, so I'm going to multiply these two together since they're the same base. So I have log base 9 of x times x plus 24. Let me simplify that a little more. That's x squared plus 24x. And now I have a single log, so I'm going to convert base exponent equals. So don't forget to convert. That's the big step. The big step. Alrighty, so I'm going to subtract 81 from both sides. And now I have a quadratic. So I should be able to use a diamond. What is that? 27 times 3, negative on the 3. So I'm looking at x plus 27, x minus 3, x equals negative 27, x equals 3. Looks like we're going to have an extraneous solution. So when I do my double check, already I can see when I plug a negative 27 here, and you always have to check in the original equation, already that's a big no-no. That's extraneous. You cannot take the log of a negative. And if I plug 3 in, so now I can double check x equals 3. That's good. And if I punch in over here, I get 27. So that's good. So this is a good answer. I just want to make sure I'm not taking the log of a negative number. Alrighty, let's solve this. And I already see a hint that I'm going to need a calculator because it says round to the nearest thousandth. They're both log base e. As a matter of fact, you might even want to rewrite your natural log problems as log base e. It just might be a little easier to look at. And so here I'm going to use that second property that we learned in the last lesson. where if it's subtraction, you divide. And now I'm going to convert. So I have base exponent equals. As a matter of fact, I can simplify that. Again, we must convert. Okay, so that's e to the 5th power. And you should be able to locate that on your calculator with no problem. So this is x minus 2. And now I want to get x by itself. So I'm going to add 2 to both sides. And now I have x equals e to the 5th power plus 2. And if you punch that into your scientific calculator, you'll get that x is approximately 150.413. Oops, forgot to check for extraneous solutions. If I plug the 150 and change right here, then this value will stay positive. So it does work. It does not create a negative number. But the most important thing in this lesson is to remember to convert. Once you get the log by itself, convert to exponential form. Also, when solving exponential problems, then you may need to convert to log form. So that's the key to solving both types of problems.